So we're going to take what we did yesterday and just kind of take it just a step further. If you haven't done yesterday's assignment, go back and do it first before you ever start this one because you're going to get confused if you don't. The idea is instead of just multiplying a monomial and a monomial, a single term and a single term, we're going to take that single term monomial and multiply it into a bigger polynomial. So it might have 2 terms, 3 terms. It just kind of depends. But it is basically using the distributive property that we used way back at the beginning of the year to solve an equation. We're going to use that distributive property to simplify a polynomial. Okay, again, we're not solving anything. We're not getting any actual, x equals 5 type answers. We're just taking these pieces and kind of cleaning them up and making it look simpler. Everything says simplify. You're simplifying this expression, simplifying that expression. You're not solving anything, again, because nothing is an equation. So before we do this, I want to, real quick, what does a distributive property look like? We haven't used this since you had to solve equations way back in like unit 1. But the idea is if I've got this expression, say x plus 5, and this set of parentheses around it and a multiplier out front, the distributive property says I can multiply, and this isn't like the book definition, this is the Mr. B definition. I can multiply this coefficient out here into each term inside the parentheses. It doesn't matter if there's 2 terms, 3 terms, 4 terms in there. Everything is going to get multiplied by 3. So in this example here, I would get 3x plus 15. You're not just multiplying the coefficients. You're not just multiplying the constants. Everything's getting hit by that 3 that's out front. So if I did something a little bit bigger, right? Each of these guys are going to get multiplied by 4. So you just one piece at a time, you're going to multiply, make sure that everything gets hit with that 4, and that's it. What we're going to do is take what we did yesterday with the exponent rules for multiplying monomials, and we're going to bring that into the fold here. So you're going to see these bigger expressions being multiplied by a monomial out front. So keep those rules in mind. Basically, the rule says, hey, I can take this term, and the result would be their exponents added together. Okay, that's the real quick summary of yesterday. So I'm going to take 4x times x. That's going to give me a 4x to the second because there was 2 x's. And then 4x times negative 3 is a negative 12x. All right, multiply here. And I'm going to go through these fast. Again, go back and do yesterday's stuff if you haven't. This is going to give me a negative 3x to the third minus 12x squared. I got an x to the third minus 2x squared. Oh, I got a new variable here. So when I do that, this term times this guy out front, there's nothing going to happen to the x because I'm not multiplying more x's into it. So my once I multiply this, that 3x is just going to slide in there, and then I'm going to get a y to the 5th. Remember, your variables need to be in alphabetical order if there's more than one. And then I've got a 15y to the 4th. Right? Remember, these single variables out here count as 1 when you're figuring out how many are being multiplied together. All right, make it a little bit bigger. 2y times 3y, that's 6y to the third minus 2y squared minus 10y. Negative 2x to the 4th minus, notice how that became a negative 12x to the third. A negative 2 and a positive 6 is a negative 12 down here. And then same thing here, I'm going to get a positive 14 on the end because I'm multiplying a negative and a negative. Integer rules still apply. If you multiply by a negative, your addition and subtractions are going to switch up depending on what you need just all throughout the problem. This one could be tricky. Negative 2p to the third, no change to the q, plus 6p squared q squared, plus, whoops, not plus, minus, back up, minus 10p q to the third. And then last one here, x to the third y squared minus 3x squared y to the third minus 4xy to the 4th. Um, Realistically, the last two are just to kind of make it a little more complicated, so you have to be neat and organized. Realistically, what we're going to be doing is more like 5 and 6 right there. A single variable, single variables, so you don't have to keep track of a whole bunch of different things. Okay. As a matter of fact, I don't even think on your homework there's any as complicated as 7 and 8. If you got through those, if you followed along with what we were doing, good. Nice little exercise to kind of keep you sharp. I'm still recording.